So, in this video, we talk about polynomial and rational inequalities. As always, feel free to stop the video and copy the notes or try to solve the examples by yourself first, then continue watch the video. Okay, so we practice solve inequality of linear inequalities. In here, we focus on how to solve nonlinear inequalities. When we're thinking about inequality, we'll be right basically it's four ways: less than, greater than, or less equal than, or greater or equal than. How do we solve that? At first, we always rearrange the inequality so one side is set to 0. In other words, for example, if you gave me like 5x plus 5 greater or equal than, say, x, then we always rearrange that to all the terms one side and leave another side 0. Second, the way we solve the inequality, which means we find the x possible, right? X values, x intervals to match the given inequality. In order to find that, first of all, to solve the equal to 0. So in other words, by solving equal to 0, we find any values of the x, make this fx equal 0 using this x value as my boundaries. And next, determine the sum of the intervals formed by the boundary points. Okay, so if the function is positive, that just means the value of x on this interval make my fx, this function, greater than 0. If function is negative inside the intervals, then the values of x on the interval are the solutions make my given function fx less than 0. Okay, so always make sense, better understanding is go through the examples. Okay, so first example, this gave me is less and equal than 15. That means including this point, right? So first of all, as we said, we need to rewrite this as one side became 0. So we give x squared minus 2x, move this 15 from right to left, became negative 15. Next, we set up this equal 0 to solve the boundary point x. In this case, I factor that, so give me x equal 5 and x equal -3. That's my boundary point. Okay, then we know we need a testing, right? Testing in the intervals is positive or negative. Here, 5 and -3 is my boundary point. Then what is my interval? Then my interval just from small to big, right? And it's a 5, -3. That's my two boundary point, and all the way to negative and positive. So then we're testing from each interval. First, I test negative infinity to -3. I pick a number -4, and then we pick a number between -3 and 5. I pick number 0. Next, I pick number from 5 to positive infinity. I pick number 6. You only need to pick one number in each interval. definitely you pick the easy one to calculate. So then I plug in this. When x, I pick -4, I plug in here, right? Plug in this given fx, I rewrite it, right? So then it's a positive number, negative, and then for the next 0, 0 gave me a negative number, so negative. For -3, pick a 0, pick 6. For the 6 will be also positive. In this case, because I need a number is equation less equal than 0, right? The question gave me is find this less and equal than 0. Less than 0 should be negative, so only this one is negative. So because it's including, right, not equal, less or equal, including this boundary point. So my answer will be -3, 5, close interval. Yeah, if you graph it, even give you better ideas. You see here's your graph for x squared minus 2x minus 15, and on this part under the x-axis, right, this is less than 0. Okay, so then we are comfortable to move to next one. Next one, actually even nicer. He already moved one side out 0 and also gave me as a factor form already. So that would be easy for me to find my boundary point is 2 and -3 because I set up this equals 0 gave me boundary point, right? So this boundary point came from. So then again, we set up my intervals from negative infinity to first boundary point -3, then 2, then positive infinity. I choose a number between each interval, choose an easy number to -4, 0, 3. You can choose a different number, but must be inside this interval. Then I testing the sign. First one is negative, from -3 to 2 is positive, 2 to positive infinity is positive. The question is asked looking for greater than 0, so that's positive. So that tell me from -3 to 2, 2 to positive infinity all match my required inequality to greater than 0. Since it's not have the underline, that means it's open interval, not including these two boundary point. So I'm using open parentheses. That'd be the parentheses. Okay. Okay, so we can see a next one more example. This one I just show you everything here. Then you can stop the video, try to practice by yourself, and then go back to check your answer. What happened to this one? I testing, okay, I saw factored it out and gave me the boundary is x equal 5 over 2. However, actually after you rewrite the given quadratic as 2x minus 5 squared less equal than 0, from here, algebraically, right? From here, you already know. Yeah, they cannot be less than 0. Only possible is equal to 0. So that means my answer is only on this one point. Same thing, if we ask a greater or equal than 0, then after you write as this perfect square, you no need to go the testing procedures. Just by the concept of algebra, we know my answer already. Because the square is always greater or equal than 0 for the whole domain.